Today we are starting 4.4 notes. This is graphing from slope-intercept. So this whole entire lesson is going to be over graphing, so make sure that you have some graphs ready. If you've got a printer at home, you might want to print out some graphs for this lesson. So let's get started. So I've got a warm-up problem for you to do. It is just like what we were doing before. I've given you a table. So you've got your x over here, your input, and you're taking that and plugging it into your equation. You're going to be simplifying it, and that's going to tell you what your output is. After you're done with getting all of your x's and your y's, graph that problem and check your answer after. And here's your answer. So I'm just going to go over the first one with you. I plugged in that -4 into my x, so it says y equals 1/2 times x plus 3. Then I simplified my 1/2 of -4. Half of -4 is a -2. I still have that plus 3. -2 plus 3 equals 1. And so I'm looking at the point -4, +1, which is going to be located right here. Each point corresponds to the color, and then you draw your line connecting them. So hopefully you got that right since it's an older problem. If not, you might want to go back and rewatch some of the previous videos. So let's move on to our next slide. There we go, clear all drawings. So if you knew that a line began at 0, 3, where would you draw your first dot? Hopefully you answer 0, 3. So we go over 0, so we're still at 0, 0. And then since that's a +3, we go up 3, because that's for our y. And so our first dot is right there. Let's move that so it's a little more centered. There we go. So that's going to be our first dot. The next question is, if you knew that the slope of a line was 1/2, where would you draw the next dot? So we have our starting point right here. We have to think about where our next dot's going to be. If the slope is 1/2, if I start here, I'm going up 1, right 1, because up is positive and right is positive. And since those are two positive numbers, I need to go in a positive direction. So that point right there is up 1, right 2, just like how that slope is. And then we can connect the dots to create a line. So it's going to look something like that. So now we have a line. This is exactly what we're doing. We start with graphing on this y. That's called our y-intercept. So this is how this equation is represented. So if I'm thinking about this being my y-intercept, where do you see 0, 3 in this problem? Well, it's right here. That 0 kind of goes away, and since that 3 is part of our y, this right here, the b, is our y-intercept. And then before we said we had a slope of 1/2. This is where slope goes. We knew that from before. And so you're going to be starting up here because it has a +3, and then we're going up 1, right 1 with our slope. So our previous lesson was over proportional relationships. Proportional relationships always start at the point 0, 0, which is why we didn't include this b. So the only thing this lesson is introducing to you is that b right there. So let's go over our entire equation. So we know that our equation's in the form y equals mx plus b. We already knew that m is the slope, but now we're learning that b is our y-intercept. Think about what the word intercept means. Hopefully you're thinking of the word crosses or something similar. It's where it crosses our y-axis. So before, we crossed at our +3. There we go. We crossed at our +3, and it went up 3 on our y-intercept. So let's try some of these problems out. Step number 1 is to identify and graph the y-intercept, which is our b. If there's no b, the y-intercept is going to be 0. So if this wasn't here, we would start right there. But we have a positive 3. So on our y-axis, I'm going to go to positive 3. And then we have a slope of a up 1, right 2. So I'm going to go up 1, right 2. I'm going to keep going with that. Up 1, right 2. I like to go as far as I can. Let's say that this point was all the way at the top of the graph and you couldn't go up anymore. Like how this point is here. You can actually go the opposite directions as long as you go the opposite on both. So this is a positive 1, positive 2, so that means up and right. But you can also go down and left. So down 1, left 2. And it should match up on a line. So if it doesn't make a straight line, you know that you did something wrong. That's your checking point. Once I have all the points graphed that I can, I'm going to draw a line that connects them. Move that line so it matches up better. There we go. And that's going to be our graph. So we started off with identifying and graphing that y-intercept. And then our second step is using that slope and graphing more points. If there is no m, so if there wasn't a number right here, that means your slope is 1 because you can always add a 1 in front of your x, which is what we did to get the rest of these 4 points. And then your final step is just connecting the points. You need to make sure that you draw that line to connect the points. You can't just leave it as singular points, because if we want to be technical about it, this point right here is still a solution. We graph because this represents every single solution of this equation. By solution, I mean what we plug into x and y. So if I plugged in this point right here, a 0 for x and a 3 for y, it would come out as a correct solution, because when I plug that in, I've got a 0 here, so that kind of makes that go away because it's multiplication. And 0 plus 3 is just 3, and then the y was 3, so 3 equals 3 is a true statement. That works for every single point on this line. But this point right here is a bunch of decimals. I don't want to work with decimals, which is why we only graph points typically where they intersect on our coordinate plane, because we like those numbers better. They're whole numbers. So let's try out some problems. I'm going to do this one with you. I want you to pause the video on the next one and we'll kind of go over it together, and then the last one will be totally you and you're just checking your answer. So let's work through this one together first. First things first, we got to get that y-intercept in place. So if we look at this equation, it's in the form y equals mx plus b. B is our y-intercept. That says positive 1. So we're going to go to positive 1 on our y-axis, which is right here. Step number 2, use the slope to plot more points. So our slope is 1 over 3. That means up 1, right 3. So from the point that we just graphed, we're going up 1, right 3. Up 1, right 3. It goes off, but I want more points. So instead of going up and right, I can go down and left, because that keeps it on that line there. So down 1, left 1, 2, 3. And then down 1, left 1, 2, goes off the graph. So I at least got 3 points on that graph. That's what I want to see, is at least 3 points. And then we draw a line that connects them all, best we can at least. And that's step number 3, and we are done with that problem. Okay, I want you to try this problem on your own. Y equals 2x. So this one is a little bit different than the last one. Let's see if you can do it. Hopefully you tried it out. So let's do it together now. Our first thing that we're looking for is our y-intercept. This one does not have a y-intercept. It doesn't say plus anything, which means it's 0, because we can always add a plus 0. So that's going to be our first point. Now we're going to use slope to plot more points. So the slope right now is 2. That doesn't mean just go up 2 and call it a day. Remember, we can write that as a fraction. So let's get out our drawing pen. We can just write 2 over 1. So that tells me that since it's a positive, we're going up 2, right 1. Up 2, right 1. Up 2, and I go off the graph. I can also go down. I'm going down and to the left to keep it on this line here. So down 1, 2, left 1. Down 1, 2, left 1. And then our last one is to connect the points. So let's connect them best we can. And then we're done with this one. So hopefully you got it correct. If not, try on the next one. So this is our next problem, y equals x minus 1. Pause the video, try it out, and then I'm just going to have the answer on the screen when you are done. And here's your answer. Hopefully you saw that this was a negative 1. So we went to negative 1 on our y. And then remember, we can always add a 1 in front of our x. So our slope is up 1, right 1. Last thing I'm going to talk about is the point a solution to the equation? So we kind of talked about this a little bit. Let's actually do some of these kinds of problems. So this is our equation that we just worked with, so I'm going to leave this graph up here. What we're going to do to figure out if this is a solution is we're going to actually just substitute these numbers into our equation, and that's going to tell us our answer. So I have x is 3 and y is 2. Remember, points are always written as x comma y. So I'm taking this equation here, and my y is 2, so I'm going to write 2 equals, my x is 3, and then minus 1. Well, I know 3 minus 1 is 2, and since 2 equals 2, that's a true statement, which means that it is a solution. So I'm going to write yes. For our next problem, we've got negative 6 and negative 5. So again, I'm just going to plug these two numbers into our equation. My y is negative 5, because that's x comma y. So y equals x is negative 6 and then minus 1. This looks really confusing to me, so what I'm going to do is I'm going to KCO it, because I can always KCO subtraction. So keep, change, opposite. That looks a lot better. Negative 6 plus negative 1 equals negative 7. I've still got a negative 5 on the right, and you're going to ask yourself, does negative 5 equal negative 7? Hopefully you say no, because those are two different numbers. And so this is not a solution. So let's think about this in this graph form, because we've got one yes and one no right now. If I plot this, 3 comma 2, let's go and plot that. We're going right 3 and up 2. That's this point right here. If I go right 6, 1, 2, 3, 4, 5, oops, that goes off, 6, and then down 1, 2, 3, 4, 5. That's like right here. So if we extend those lines, give me a second. There we go, that's better. So the question is, does this point right here fall on this line? And the answer should be no, because if we take this and we extend it a little bit more, it goes way down here. It avoids the line. It's kind of close, but it's not on the line. Every single point that falls on this line is a solution. And so when we're thinking about using our x and our y variables, we're thinking of those variables being points on our graph. And so this x and y is a solution. This x and y is not a solution. So I want you to try this last problem, -9, -10, and see if this is a solution to this equation up here. And hopefully you answered yes, because y is -10 and x is -9. When I take -9 minus 1, that's going to give me my -10. And since it says -10 equals -10, I know that yes, that is a solution. So if I went and graphed that when I had my line extended down that far, it would fall on this graph here. So now I've just got two questions for you. The first one, and this is just like a review, so hopefully you get a better understanding if you're thinking about what these questions actually mean. That's my goal. So my first question is, what is slope-intercept form? My second question is, what does each letter or each variable in the equation stand for? So think about your answer to those two problems. Hopefully you said slope-intercept form is y equals mx plus b for one, because that's the actual equation. You could have also said something along the lines of slope-intercept form is a really easy way to take an equation and turn it into a graph. So it's a really easy form to graph out of. And then what does each letter in our equation stand for? Well, let's write out our equation real quick. Y equals mx plus b. M and b are easy because m is our slope, b is our y-intercept, x and y represent solutions to our equation. And so when we write an equation down, it typically looks something like this. We leave those x's and y's blank because there's tons of different options. There's infinitely many possibilities for this equation because it's that continuous graph. It's that line that goes on forever and ever, which is why x and y are blank, but we have m and b filled in because those things never change. It's what makes our equation, and it's what builds our graph. So now that we've got our notes done, you've got a couple of homework problems. This is in your textbook, page 170. If you've got any questions over the notes today or the homework, please be sure to email me.